Okay, the old infamous passing problem in physics. Alright, this is what you guys did when we did the walking. Okay, you have your line that you had to get to, and it was 50 meters. There's a 50-meter distance. Here's the 0. You had a person start right in the middle of it at 25 meters. Okay, so you have person A that was down here. A, you had person B that was down here. Okay, so person B only had to walk 25 meters. So now let's say that person A walks the distance in a time of 39.3 seconds. Let's say person B is slower and walks that distance, which is really 25, in a time of 42.7 seconds. At what point will person A catch person B? Okay, probably going to be somewhere around there, but we don't know yet. Well, first of all, we have to find the velocity of A. Okay, so the velocity of A, displacement over time. If person A went 50 meters in approximately 39.3 seconds, their velocity is going to be roughly 1.37 meters per second. So that's the velocity of A. The velocity of B, okay, the velocity of B, they went actually a displacement of 25 meters. And they did it in 42.7 seconds, so much slower velocity of about 0.59 seconds. Okay? So now what we're going to do is, we notice that there's a gap. Notice that there's a gap between here and here. Okay, we notice there's a gap between there and there, and that gap is going to close. Both of them are moving at the same time. We also note that this starts 25 meters ahead of that one, so we have to factor into it. Okay? So we're going to find the difference. The difference. In other words, we're going to subtract. What we are going to subtract is, in order to find the distance closing between the two, because they're going to cross somewhere around there, we have to move velocity and time together. Okay, we have to move velocity and time together. So, right here, this equation would be the displacement of A, okay, is equal to the velocity of A times time, and the displacement of B is equal to the velocity of B times time. But that can't be really the case because we started at 25. So, to rearrange this,
please call 1000.
okay, the final displacement of A is going to be velocity of A times time plus your initial displacement. Well, the initial displacement for him is 0. What about for the purple guy? Well, your final displacement is his velocity times his time plus 25 meters that he started out with. So remember, we're going to try to find the difference between the two. Let's try to find the difference between the two. Okay? So, we're going to subtract the two equations. So we have the velocity of A times t minus this equation. Okay? Bracket that. Velocity of B times t plus 25 meters. And since they're eventually going to pass each other, we're going to set that equal to 0. So what time do they meet? That's 0. Now we can plug in the numbers. So now it becomes basically an algebra equation. Okay? So we've got 1.27 meters per second times time. We're going to subtract, we're going to distribute this negative, and we've got 0.59 seconds, excuse me, that was the time. We've got the velocity of B, which is, 0.59 meters per second, meters per second. 0.59 meters per second. Okay, t. Okay, minus 25, because we distributed this negative right here. So minus 25 meters equals 0. Okay, so we're going to subtract these two like terms here. We're going to subtract these two like terms.
Save Harris Field.
Why do you have to
If
shout
you're
from
in
the
the
town?
building, come to the main office. Save Harris Field. Please come to the main office.
Okay, so after we subtract these two things, right here, these numbers, we're going to get 1.27. No, we're not. No, we're not. Nope. We are going to get we are going to get thing 0.69 meters per second times t equals 25 meters. So if we solve for t, time is equal to 36.2 seconds. So we're going to cross when they meet, it's 32.2 seconds is when that'll happen. Okay? Now, what is the distance? So that's the time that it happens. What is the displacement that'll happen at? All you got to do is think of it from this guy's perspective. Think of it from this dude's perspective, okay? Because he's the one that has to go the most distance. So when he walks for 36.2 seconds, where will he end up? All you got to do is take his velocity, multiply it times that time. So his displacement will be 1.27 seconds, so 1.27 meters per second, 1.27 meters per second, times 36.2 seconds, and this dude will have gone 45.99 meters. So at 45.99 meters and 36.2 seconds, these two walkers will have crossed. Okay, now let's look at a graphic representation. Okay, we got that? Good, let's go over the graph. All right, here people actually did this. These were human beings that actually generated this data. Okay, we had to flip the distance in time, but that's okay, because this is the displacement, and the displacement, as you can see, is approximately 46 meters, and the time is approximately, oh, that's too much, is approximately 36 seconds, about 36 seconds. Okay? Sorry, I can't draw in straight lines, but maybe I should draw in straighter lines. Let's see here. Straight line. Let's go. Straight line. Right there. And right there. That's about 46 meters. About 46 meters. And was about 36 seconds. And I moved the damn thing. Stupid for moving forward. Come on, man. Come on. There. Okay, so we've got this represented graphically, and we have it represented also algebraically. Got algebraically represented. And that is the classic passing velocity problem. Passing velocity problem. You got to subtract the two equations. You got to subtract the equations to solve for time, and then use the time to solve where the displacement crosses. Hope that helps.